Evening all. So I picked this up off of eBay recently. It is it's an Xyloband or something along the lines of that. It's a flashing wristband that the attendees of the Coldplay concert wore, and they all kind of flashed in time with each other. From what I've read on the internet and the video that I saw, I'll get onto that in a moment. The other videos that I saw about it I'll discuss. But from the videos that I saw, they seem to be controlled by some sort of radio frequency. Now I heard about these on TheAmpHour, and Dave Jones and Chris Gamble kind of gave me the impression when they were talking about it that they were controlled by some sort of IR cannon. What probably would have been a cheaper way of manufacturing them than being controlled by radio, but I don't know if with an IR cannon it's harder to get a kind of data packet out to these devices if it's kind of on or off. So there would have to be more in-depth kind of programming in here for the light patterns, and you may find that they will kind of drift out of time. Some may start sooner than others, some may not start at all if it's kind of, this is kind of under the arm, you know what I mean? If this receiver, for example, was like this, then obviously it wouldn't pick it up at all. So radio frequency is probably one of the best technologies to use for something like this, but it's most definitely not the cheapest. So maybe there are other products out there with the kind of IR cannons, but this one I'm pretty confident is a radio kind of enabled one. I watched a video on Carlstechshed, a new YouTube channel that everyone should check out. I'm a firm believer in kind of UK content producers, especially in the kind of electronic and hobby electronic fields. So yeah, check out Carlstechshed, the link will be below. And he got one of these. He picked one of these up off of eBay and he did a quick teardown, and that was good. But I noticed, and I commented on his video about this, I noticed that he overlooked something on here that was what looks like a some sort of kind of serial programming interface. So I picked one of these up off of eBay with the intention to do a teardown myself, have a closer look at it, and then maybe try and hack the firmware or put a kind of different hack video out there on how to hack these products. Yeah, because they're brilliant, you know what I mean, they're pretty solid. I'm stretching that there with my hands. They're not cheaply made. It's a nice kind of, that plastic there is you know what I mean, it's not kind of cheap plastic, so they're not cheaply made, even though it does say made in China, but well, good things can come from China as well, can't they? So anyway, enough rabbiting on about this. I'm going to pause the video. I'm going to take these 4 screws out. I'm going to pop it open, and then we're going to kind of have a look at what's inside and see if I can get to some kind of programming interface that hopefully will lead down a couple more a topic for some more future videos that I plan to be producing. Cool, catch you after the break. Right, so I've now taken the top cover off here, and it's exposed the inside. So let me just quickly run you through what was in here. So what it looks like we have is like a kind of plastic cap that has two of these batteries in there, and then batteries are a it's a 2016. Let me just turn it around. Have a bit of a better idea. They're 3 volts, so that's kind of giving us a combined 6 volts. Now I have tested them on the multimeter, and they are registering at about 2.98. So pretty much 3 volts. Don't look like barely any of the juice has been used in them. We also had another one of these batteries. Now these are kind of more common. These are Si4313s. It's what they have on Adafruit and stuff sell, the kind of battery compartments for these kind of devices. I've measured this, and this is as flat as a dodo. So yep, no juice left in that. It's quite interesting, the configuration of them, because we had these 2 batteries, these 2 here, in the plastic cap, and they were actually on, they were in here. And then on the other side, this plastic cap, oh, let me just get that in focus, sorry, I'm still learning to be a bit of a better cameraman. And this has a kind of plastic retaining clip on. Now when I first opened this, I was slightly disappointed, because I thought this version was a different version than what I had seen on Carlstechshed, and I was kind of hoping to get hold of I was hoping to get hold of one of the boards that had what looked like the kind of serial interface brought out on it, the FTDI. I'm pretty sure the terminology is FTDI SPI, the serial interface, the programming interface. Now this has a couple of pins exposed on this side. Now what I'll do is I'm actually going to remove these metal straps shortly, but I'm just going to give you a quick tour of the board. So over here we've got some programming interfaces, and then as you can see in here we've got a kind of TX and an RX, two pads there just underneath the metal strap. Can you see? TX and RX. And then let me just flip the board over. So this is the board flipped over now, and as you can see there's another kind of battery compartment here. It's quite it's an interesting way that they've done the battery, because what they've pretty much done is put some kind of solder balls, kind of solder pads, lumps kind of on there to make the ground side of the battery connection. I believe that's the ground side. Yes, it is the ground side. The ground side of the battery connects onto these solder pads down here. What's quite interesting. And then obviously this plate up here provides the positive side of the battery. Now my concern when I first got this was, oh well, when I watched it on Carlstechshed, I remember him turning the board over, so I remember him demonstrating these pins here, or me seeing these pins. I can't remember if he actually mentioned them, but I remember seeing these pins, this TX and RX pin here, and these other power and what looks like data pins or input output pins kind of exposed on the board. Then he turned it over, and there was pins on the other side, and I was slightly disappointed not to find them. And then I realised that I'm going to have to come out with quite a wide shot here, and I'm going to have to do a little bit of jiggery pokery with the camera But if we remove this, plastic clip here, and kind of push that through like that. Come on, out you come. Let's do the other side as well. Sorry, I really do need to get a tripod for my camera. I'm just using my iPhone at the moment. So let's just push that through there. Oh, come on. It's being a pain in the arse. Sorry, bear with me. There we go. There we go. And the plastic. Oh, you know what, that can stay there. And then I found these pins. And these pins made me more happy. Because let me get a better angle like that, where we've got some light. Let me move that out of the way as well. There we go. So then I got a little bit more excited because we have these pins. And as you can see on here, we've got the MOSI and the MISO and what looks like a serial clock. So that, I haven't traced these traces yet to see what I see on this side of the board it goes to, because there's actually two ICs. I believe this is the chip responsible for the radio communications, and I believe this one under there, you can just about see it under there. I'm going to point to it with my tweezers, that in there. This in here looks like the microcontroller responsible for flashing the LEDs, and then the LEDs just kind of go up the strap like this, and then they're just connected with a they're just connected through what looks like some kind of MOSFET driver there. So I'm going to remove these. I'm going to remove this. I'm going to actually desolder it instead of cutting it off. I'm going to desolder that, and then we'll come back and have a look to see what chips are on there, and maybe I'll do a little trace to see where them pins on the other side lead to. Hoping that they lead to this microcontroller under here. I'll then call it a day for this video and start producing the second video, what will be acquiring, probably I'm looking at getting a bus pirate probably, and then connecting it up to these and seeing if we can get this thing talking to see if there's any kind of debug data coming out on the serial lines. Yeah, if there's any devices that people kind of recommend that could do this cheaper, that allow me to just tie into these lines down here. Sorry, my font's massive compared to these tiny little pads. Anything to tie into these pads down here and get a serial interface, then yeah, leave the comments below. I'll unsolder that and then we'll take another cut and have a look to see what's going on. Cool, catch you after the break. Right, so I've removed the battery straps now. As you can see, we had a battery strap that went from here over here to here, and then we had another battery strap that went from here across to here. This one was doing the ground and this one was doing the positive off of the battery. If we flip the board over, then I also removed the battery strap that went from here to here, providing the positive, and then these soldables that I mentioned on a previous video provided the ground connections. An interesting way of doing it. These solder pads here are the ones that I'm most excited about. As I said before, we've got the MOSI, the MISO, and what looks like a serial clock, an IRQ, some sort of select line that says SDN, and that's a ground connected to the ground port. All of these look like they all come up to here, although they all tap off over here. I'm not sure where. I haven't traced any of the traces yet, but on a quick inspection it looks like they're all coming from here through there and then leading on to this chip here. What is the microcontroller? So we have this, what's our radio interface chip, and this one, what's our microcontroller. We then, let me just spin that around so the text is around the right way. So we've got VDD here, this pad here and this pad here look like input output pins that they've exposed off of the microcontroller. Got grounds there again, and then we've got a TX and an RX. I'm not sure where they're from, but well, actually I am sure where they're from because they're coming up from here. So I'll have to have a little look into the datasheet on this chip and the datasheet on this chip and find out what these TX and RX pads are for, and if we were able to make any use of them actually. These are also quite interesting, this and this here. What they look like to me are solder bridge, kind of jumperable solder pads. So you'd solder a connection in there and it would close the contact. So it's like a switch, it's a solder pad. I'm not sure what they're for. I'd need to trace them out to pins on the microcontroller or onto this radio interface chip and see if they do anything, and if they do, what we could possibly use them for. It says GPIO here, what it looks like. Bear with me, let me see if I can zoom in some more. No, I can't. Oh, yes, I can. Perfect. So that looks like GPIO 2, maybe. I'm not sure. What grounds GPIO 2? So potentially this may put it into some sort of test functionality. I'm not sure. We'll have to look into that. Right, so I think that's going to be the end of this video now. I've done a bit of a teardown. I've done a bit of a kind of tour. So I don't think there's anything else on the board to show you. This looks like the crystal to provide the clock signal for that, and then I don't see any crystal for this. So maybe it's getting some sort of timing clock signal from this chip. I'm not sure. And there's nothing on the other side. It's just plain. There's no components or passives or anything on that side. So yeah, I think that's all. If you like this video, then please subscribe. Leave your comments down below. Oh, right, down below. And I'm gonna go away and look at how we can, what tools and functionality there is in stuff like the Bus Pirate and UART. In UART interfaces, USB to UART interfaces, that I might be able to take advantage of this serial connection here. Yeah, if there's any help or guidance or comments that you might have on this, please leave them in the comments below, and I'll catch you next time. Thanks, bye.